If your maytronics robot stops and it has a swivel connector, the most common place for water to leak is the swivel. Grab a set of channel lock pliers, open up the swivel. Some will have double O-rings like this one. The double O-ring is not any better than a single O-ring. Water has leaked inside and caused a short. The salt water reacts with the DC current to burn out the connection. This video will show new ideas to fix the connection. If we can fix the connection, we still need to seal the swivel. We clean out the rusty water. We have to see if there is any continuity. It is easier to repair this side compared to the pin side. We can repair this type of damage, but when the pins are destroyed, we need a new cable end. I will cut one of these up later in another video. Use channel lock pliers or a hose clamp to tighten this clip to remove it. Sometimes the clip is brittle and can break. Use a fine Dremel bit to grind through. We are looking for continuity in 3 places. This is damaged badly in 2 of the 3 rings. This repair method will work for all repairs. Use a multimeter to check for continuity. Copper tape method. Originally I used copper tape. This is used to put around the garden to stop snails. I cut the tape to match the pitted rings. Small areas of the tape are joined. We try and not have too much solder. The copper is very thin. This method works quite well, but we do not want solder exposed. The copper is thin and may wear prematurely. Copper wire method. Get some solid core copper wire. Bend the wire to the same size rings. Check to see that your ring is the correct circumference. Hammer the ring flat. Trim a small recess for your new ring. Do the same for the smaller ring. Hammer and then trim the copper. Test for continuity. Use some epoxy resin to set the rings in place. Check that there is no connection loss. Connect up your swivel and spin the cable. If there are areas of signal loss, you can add more copper. This is not recommended. I have included it in this video to show what can be done. Ideally, you do not want solder showing. The solder can corrode easily in the presence of salt water. The solder is smoothed back with a scalpel and then a file. Copper plate repair. We will repair all 3 rings here. All are badly pitted and cause signal loss. we want a 19mm, a 12mm, and a 6.8mm ring. I find a copper bracket and hammer it flat. We want the copper thin and larger. The copper will be used to make 3 rings. This is the 19mm larger ring. You can see how thin this is. We will also sand this a bit thinner. The sanding will allow better soldering. The rings are cut using fine Dremel bits. I hold the copper with vice grips as it heats up a lot. Drill bits are used. The rings cannot touch each other. The small center ring is a bit fiddly to file. Here are the rings ready for sanding. Sanding takes out the hammer marks and allows a better join. The pitted contacts are cleaned up. Solder is tacked in areas of the swivel plate. We do not solder all around or else the copper rings will sit up too high. So we flow some solder onto the connector. The copper ring is placed over the solder. Copper is heated until the underlying solder melts. We are aiming to have copper with no solder showing. Here I hold the small center ring with a probe. The probe holds the ring and the iron heats it. We make sure there is continuity. The center is heated more until it joins. A larger soldering iron flows the underlying solder better. With all 3 rings soldered in place, epoxy resin is used to seal the gaps. This also seals moisture from the underlying solder. Make sure to seal the swivel. Use a silicone grease to seal the swivel O-rings. Squirt some grease into a syringe. The syringe tip is usually too short. Heat shrink tube is used to extend the syringe reach. You need the silicone grease around the internal O-ring. Looking through, you may be able to see the O-ring. You may try to apply grease from the inside as well. Make sure you grease this O-ring as well. Thanks for watching.